What is up, stats nerds? Professor Charlie Collins here with another edition of an SPSS demonstration. Today, I'm going to demonstrate running a exploratory factor analysis for scaling. And so we're going to do some psychometrics here, some psychometric scaling. Hold on to your seats. This might be a little bit longer than some of my other videos. So we've got a bit of a slog today. So just hold on tight. So today we're going to go through exploratory factor analysis. I'm going to go through each of the components there. That's going to take a little bit of time. Then we will talk about doing the scaling, looking at internal consistency and what that looks like. So without further ado, let's jump into it. All right. So we have our data set here. So this is the GSS, the General Social Survey data from 2018. 2018 is the most recent SPSS data they have. And so I have this on my second screen here, so you'd be looking at the side of my face for a while, so excuse me. So first what we want to do is what an exploratory factor analysis does is it looks at the underlying variables that somebody might be interested in, right? So if, in terms of a construct, right? And so today I'm interested in the construct that we might call confidence in American institutions, right? And so there's a series of variables within SPSS that start off with CON. And so we'll run down there right there. So starting at Con Army and all the way down through Con TV, or actually Con Workday. And so what we're going to look for here is any of these variables that say confidence. All right, confidence in the military, confidence in education, executive branch, confidence in the United States Supreme Court, organized labor, so on and so forth, right? And so what I'm interested in here is developing a scale that gets at confidence in American institutions, right? So citizens' confidence in American institutions, and creating a scale that really touches on those different factors, right? And so creating a scale that really gets at those different components of what could be trust in American institutions, right? And so what I first want to do is you can't run a factor analysis. So that's what exploratory factor analysis does. It looks at those underlying factors, right? And really sees if they are something that kind of form together to create a valid and reliable construct. Okay. So this is the beginning of steps of this. And so what I want to do is you can't do this unless the scaling, so the measurement is the same, right? So even if even if all, let's say, variables are ordinal, if some have, let's say, 3 response options and some have 5, we can't put those together, right? So we need to make sure they're consistent across them. So what I want to do first is I really just want to run some basic descriptives, right? And so go to my Analyze tab, and I'll do descriptives. The nice thing about descriptives is it gives us a nice little graph that shows us the minimum and the maximum, so we know the range, right? So we'll go all the way down to our CON. Okay, and so we're interested in our Con Army, confidence in the military, business, all the way down to confidence in courts. So Con Court. Okay, I'm going to select those, put those over. Then I'm interested in Con Fed. So Con Education. Move that over. Con Fed. Move that over. Confident in the executive branch, confident finance, so that's the confidence in the banks, confidence in the U.S. Supreme Court, so that'd be con judge, con labor, con legislation, confidence in medicine, confidence in the press. Move that over. If you I should note here that if you hold control, you can select multiple variables within this list. So we have compress, and then do we have any more here? We have con schools, con science. So wait a minute, went too far. Con schools, con science, move those over, and con science, consent is consenting, so that's not what we're looking for. And then con TV is confidence in television. So we'll move that over. Great. So we got them all. We don't really need any options or anything. It'll just run it for us. So we'll click OK. As I usually mention, I like to do paste just so I have my syntax in this. And so let's run that. And so as you can see here, we have several variables that have a minimum of one, or they all have a minimum of one, which is great. But some have a max of 3 and some have a max of 5. And so because there's far more variables here with a max of 3, we'll just only select those variables with a max of 3, right? And so now what we want to do is, so we know which variables we have, and now we want to run our exploratory factor analysis, right? And the way that we do that, I'll just keep this open so that way we have the output here open, and so we know which variables are which. So what I'm going to do, go to Analyze. Then I'm going to go to Dimension Reduction, right? And I'm going to go to Factor. And so factor analyses, I was kind of playing with this earlier. Factor analyses are interesting because there is a ton of underlying statistics to this, and really a ton of matrix, what's called matrix algebra, that I'm not going to get into here. I'm just looking at the application of this, right? And so we got our variable names here, and we want to go down to our con variables. CON. Here we go. Okay, so we only want the ones with 3s, right? So we want con army. We want con bus. It's going to take me a minute. Con clerge. Con ED. UC, con EDUC, right? Yep. Con education. Okay. Con fed. These are kind of mixed up. That's a little annoying. Con fed. Con finance. Con judge. So a con judge, con labor, con legislation, con medic, con press, move all those over. And then we want con sci and con TV. So con sci and con TV, move those over. Great, so we have all of our variables in the model here. Then I like to run univariate descriptives. The initial solution. It can create some noise here, so we don't necessarily need to. And then click OK there. Extraction method. We want to do a principal components, and we want to do a correlation matrix. Again, there's a bunch of underlying statistics here that we don't need to get into right now. And what I want to do is I actually want to do based on eigenvalue. And the eigenvalue, what it does is it shows you, and I'll show you in the output, it gives you essentially the number of factors that all of these different variables create, right? So all of the different underlying variables create X number of factors, right? And so you'll see what I'm talking about there. And so it helps us understand essentially where that cutoff is. And so the general rule of thumb is a 1. So when your eigenvalues are at 1 or above 1, I should say, then that's your cutoff. But there's another thing here called a scree plot. That's not it. So go to scores. No, we don't want to save anything. Where's the scree plot? I keep losing the scree plot here. Let me find it. Extraction. Scree plot. Oh, I have it clicked already. So we have our scree plot here, and that'll show us a plot, and I'll show you how that's helpful. So we're good. So we can click OK. Again, I like paste, but we'll go with OK. And as you can see here, here's all of our data, right? So this is our descriptive statistics that we ran earlier. We're looking at minimum and maximums there. These are, again, our descriptive statistics for each of our variables. So it gives us our mean, standard deviation, and our sample size for each one. Because we did a list-wise deletion, it's deleting any cases that don't have a full responses on all of these variables. This is the correlation matrix between all the different variables in this model. Don't need to worry about this too much. It's just something that I like to have to look at the sort of the cross correlations across all the different variables. And commonalities, we can kind of look past that. And so these are the two things that help us understand how many factors we have from this. So this total variance explained and this scree plot. All right, so let's first take a look at this total variance explained. So what we're looking at is this number here that says total, right? And so typically our rule of thumb is anything over 1 we would consider to be a factor. So at the sort of onset, this looks like it would be 4 factors, right? But that's not a hard and steady rule of thumb. So a bit of this is scientific, a bit of it is kind of up to the researcher, right? And so the second one here is we have the scree plot. And typically what we're looking at is we call it the elbow, right? And so where does the scree plot start to jut up, right? Where does it start to really expand? So we know we have at least 1 factor, which is great. And we know at least we have 2 factors. So now it's sort of the up to judgment of whether or not we want 3 or 2 factors, right? Sort of up to us. And so I would probably go ahead and do 2 factors, but really you can play around with it and try 2, try 3. It's up to you as the researcher to see. So I might try 3 just to see how it runs, and we'll see. And this is our component matrix. This is another thing we kind of can ignore a little bit, but we're really interested in our rotated matrix. And so what our rotated matrix does is it tells us which variables in this analysis load. It's called loading, right? These are called factor loadings. Which variable loads, which variable loads onto which factor, right? And so what we're really looking for here is, and this is kind of a rule of thumb as well, is anything that's over 0.5 is part of that factor, right? And so I'll just open this up and we can take a look at it. Move that over. So, right, so this first factor would be made up of these 3, this one, and that's it. So those 4 variables would make up the first factor, right? The second factor would be made up of this one and this one, right? And the third factor would be that one. And then so we can kind of go down the line, right? So we're really looking for any factor loadings that are greater than 0.5. But because we are thinking that this might be, I'll call it 3 factors. We'll try it's called a 3-factor solution. We'll try a 3-factor solution and just see what we get here. So I want to go back, do the same thing, go to dimension reduction, factor, and really the only thing I'm going to change here is the extraction, right? And so what I want to do here is go fixed number of factors, and I'm going to say I want 3 factors, okay? And so we'll start there. We'll look at 3 factors and see how it goes. Go to continue, go to OK. And we can skip all this stuff since we've had it before and just go straight to our rotated matrix. All right, I'll open this up and we can take a look. So again, looking for anything for 0.5. So factor 1 would be made up of these 3. These 3, these 2, this one. So it would be these 5 variables that would make up factor 1. So confidence in the Army, major corporations, religion, federal government, banks and financial institutions in Congress, right? So part of this is also kind of a face value, looking at this at face value, right? So do these variables seem like they are getting at some sort of latent variable, right? These underlying variables. And to me, it makes sense, right? These are fairly large institutions, right? You're talking about the church, banking, federal government, Congress, right? So these things are sort of large institutions. So now we'll do the second factor, 2, 3, 4. So we have four variables there that load onto the second factor. And this is confidence in education, confidence in organized labor, confidence in the press, confidence in television. Again, face value, this seems legit to me. It seems like it's not necessarily the macro level institutions, more of a sort of a lower level institutions. And last but not least, let's check out our other ones. Our third factor. So we got scientific community, confidence in medicine, and confidence in judges. This one doesn't make as much sense to me, but we can kind of look at the reliability and see if that helps us out at all, right? So yeah, confidence in medicine, judges, and television. No, medicine and the scientific community. Yeah, maybe like professionals, right? Something like that. So let's close this out. And so now we're going to run what's called a reliability, right? And so reliability looks at the internal consistency of these variables. So essentially what the internal consistency is it says if I score at this level on a certain variable, am I likely to rate the other variables similarly? Right. So I'm not sort of all over the place. So we call it hanging together, right? Do these variables hang together? Essentially, is what it is. And so the way that we do that, we go to our analyze button, scale, and we want to do reliability analysis. Okay. And we'll go here and we'll switch this to variable names, and then we'll go all the way down to our CON. So we'll do each of those factors, right? So we'll start with the first factor. So the first factor is con army, con bus, con clerge, no, yeah, con clerge, con fed, move those over so we don't lose them. This is not what I wanted. I didn't want that one. I don't know why that stuck there. Ooh, boy. This is a big data set, so bear with me here. Okay, we're back in it. Okay, we got confed, con financial. Did we get confed? Confed, yeah, con financial. And then con EGLS and from Congress. Great. And so we don't really need much statistics with that. So one of the things I do like is if you go into the statistics button here, it'll bring up this dialog box. And what I like to do is descriptives for the scale. So if this were scaled together, what would the descriptives be for that? So mean, standard deviation, so on and so forth. And then scale if the item was deleted, right? So it tells you the alpha level. And so when we run this, we're really looking for ideally alpha level of 0.8 or higher. That's sort of a acceptable range. We can go down to, let's say, 0.7, but really below that, you're kind of getting into muddy waters where it's not as reliable. So I'm going to run this. We're okay here. And we'll click OK. And that will give us our statistics, right? And so this gives us our scale statistics, the mean. So this is a mean if we added everything together. Variance and standard deviation. And our Cronbach's alpha is 0.714. So decent, right? It's not highly great, but it's decent. And so really think about the way this is constructed, the way these data are done, and the way that factor analysis runs this, we have some challenges on this particular data, right? And so the two main challenges are the fact that we have few items, right? So really what we find when doing something like factor analysis is the more items we have in the factor analysis, the stronger the reliability is. And the wider the scaling, the stronger the reliability typically is, right? So it's very much influenced by those two things. So if you have a lot of variables, right, 10 or so, and you have a rating scale of, let's say, 1 to 7 on an ordinal scale, that's typically going to be more reliable when you run an analysis like this, right? When you run a factor analysis. So I'll go through that again with the reliability analysis, and I'll bring that all back. And so now I am interested in the second factor. So we'll do the second factor here. So we have con education. So I'm only going to do these two, and I'll leave the third one because I don't want to spend more time on this. I think y'all get the idea. So con education, con labor, and con press, and con television. All right, good there. We can run it. Boom. Cronbach's alpha is 0.55. It's not good. So we will not accept this as a variable, right? So we won't create a variable out of this. I'll just run the last one just because. So let's do this last one. We'll come back up here. And then the last factor we're looking for con judge. All right, con judge. Con medic. So this is sort of the trusted professionals, I would say. And scientific community, con SCI, right? And so we're getting, smaller number of variables, only a 3-point scale. It really limits our ability to run a decent reliability on this. So we'll see. I don't expect a strong reliability here. Yeah, 0.64. So it's better than the other one, still not acceptable. So I wouldn't use this as a variable. So what all of this tells us, right, is that we could do a single factor for this first factor. So for our con army, con bus, con clerge, confidence in religion, confidence in government, so on and so forth. So let's quickly create that scale. And so what I want to do here is I'm going to go to transform, all right? And I want to compute a new variable. So there are different ways to do this. You can do, there's a whole variety of ways to do this. So you can sum the different variables together. My go-to typically is a mean, so taking the average across all of the variables and assigning that score. There's sort of theoretically different ways to do it. The mean, doing an average scaling or a mean scaling is the typical way to go. So I'm going to call my new variable. I'm going to call it inst. I'm going to call it inst con. So it's institutional confidence, and I'm going to call that trust in institutions. So I can label it trust in institutions. I have that labeled already. So continue there. And the numeric expression is mean, open parentheses, CO. So we have to find our CON. So con army, con bus, con army, comma. So we have to put a comma there. This is where SPSS gets very picky. So con bus, con clerge, con fed. Okay, make sure we have our 1, 2, 3, 4, 5, 6 factors. We have 1, 2, 3, 4 right now. Con financial and con legislation. Great. We'll close that. and we can paste it. And so we can click OK there. It runs behind the scenes for us. And then what I want to do is go to Analyze, and I really want to run those descriptives just to make sure everything worked. So frequencies, and SPSS always places new variables at the bottom. So we go straight to the bottom, go there, right there. And so now I should have done descriptives. I did frequencies instead, but you can see the range of frequencies there, right? So going from 1 all the way down to 3. And so that's the way you create. It's sort of a long process, but that's the way you create new variables in SPSS. Again, I really like using syntax for this. It makes it much faster. So in projects I've done, if I've created 100 variables very quickly, with basically using SPSS syntax, right? And so that's more ideal in this situation. But you can get through it in this way that I just showed you. So that is how to create a variable. That's how to analyze using factor analysis and looking at internal consistency and then computing a variable. So thanks for sticking with me. I hope this was at least a little bit entertaining for y'all. Thank you, and I can't wait to see you next time.